Hi everyone, in this video we will be reviewing how to solve compound inequalities, and what's most important is that we are able to know the difference between and compound inequalities and or compound inequalities, and they're really completely different, so to keep the differences really organized in our mind. Okay, so first of all, an example of an answer of an and problem would be like x is greater than 1 and x is less than 4, compared to either x is less than 3 or x is greater than 5. Okay, so our answers are always written in this way. You know, for and problems, both have to be true. So x has to be greater than 1 and x has to be less than 4. Whereas for or problems, either x is less than 3 or x is greater than 5. So or problems are either one or the other. Okay, so that means that for and problems, it's where both of them overlap. And for our graphs here for the or, we are finding, so basically combining both graphs together. Okay, so if we graph this on a number line, then the graph would always be between two numbers for and is always between, versus for or, it will always be in either direction. So we have 3 and x is less than 3, so it's going that way. Or we have 5 and x is greater than 5, so going to the right. So either in one region over here or in the other region over here, but it's impossible to be both at the same time. So doing the first example here, okay, so what we see first of all is there's two inequality symbols. There's this one here and this one here. So since they overlap, I'll write in overlap, then this has to be an and problem. So I'm going to label the problem as an and problem. Now I'm going to go ahead and solve it. So since it overlaps, we really have three sides, and we have to undo to all three sides. So I'm trying to get the y by itself. So I have to undo the plus 2 right here. So undoing that minus 2, minus 2, minus 2. I'm doing it to all three sides. Draw the line, bring down the symbols. So plus 2 minus 2 cancels. You get y. 5 minus 2 is 3. And 11 minus 2 is 9. That means that our number y has to be within 3 and 9. Write that on a number line then. We'll draw a number line with the key numbers 3 and 9, and these are closed circles because it's equal to. And our number y is between 3 and 9, or within 3 and 9, so it's that region right there. Another example, I'm going to label this one as an and problem because it's written together versus written with two separate problems combined with or. So since it's and, then we're going to go ahead and solve it. Okay, so first thing is we have minus 5 here to undo. So to undo minus 5, we will add 5, add 5, add 5 to all three parts. Okay, so draw your line, bring down the symbols. Then the 5's cancel, so 4p is greater than 8, and 4p is less than or equal to 20. So getting the p by itself, I'll divide by 4, divide by 4, divide by 4. So p, and then my symbols. p is greater than 2, and p is less than or equal to 5. So graphing that on a number line, here's my boundaries, 2 and 5. 2 is actually an open circle versus 5 it's equal to. So for 5 we have a closed circle, and we're darkening in between that region since it's and. In this problem we know that it's an OR problem because it says it, and it joins these two problems together. Okay, so we're just going to solve each problem individually. So plus 1, draw your line. 6x less than negative 6. Divide by 6. Divide by 6. X is less than negative 1. Okay, over here, minus 1, draw your line. 2x greater than 4. Divide by 2. Divide by 2. X is greater than 2. And we have to write the word OR in between. If I don't write the word OR, I don't know if it's an AND or an OR problem. So that OR, writing the OR is 4 points, and that's essential. Okay, so graphing this on the number line, we're going to write in our line, and we're at negative 1, and we're at 2. Okay, so both of these are open circles because they're not equal to, and it's less than negative 1, so that region, and it's greater than 2, so the region larger than 2. In this problem, I automatically know it's an AND problem because it's written together. Okay, so solving for x, so it's x plus 3 over 2, so the first thing I'm going to want to undo is this divide by 2. So I have to multiply all through by 2. Okay, so one way to write it would be to just put the whole thing in a bracket and multiply by 2. So that's going to distribute to all three parts. Okay, so then we'll have negative 4, bring down the symbol. Then here, the 2's are going to cancel, so I'll get x plus 3 less than, distributing the 2 is 8. So all I did was multiply 3 by 2, and I have x plus 3 in the middle is greater than or equal to negative 4 less than 8. So minus 3, minus 3, minus 3. Bring down the symbols. 3's cancel. X is greater than or equal to negative 7 and less than 5. So on the number line, here's negative 7, here's 5. It's equal to 7, so closed circle. Not equal to 5, open circle. And we're graphing between, because those values in between here correspond to the possible values of x. Last one for the video, so this is an OR problem, so solving each one individually. Minus 7, draw your line. Now that negative is attached to the x, this negative is attached to the x, so we're going to bring down negative x less than 1 minus 7 is negative 6. So getting the x by itself, divide by negative 1, divide by negative 1. And when we divide by this negative, here, negative 1, then that means we have to flip the inequality. So x is greater than negative 6 divided by negative 1 is 6. Bring down the word OR, because we need that word OR. And for the last problem, divide by 4, we'll have x is less than or equal to 12 divided by 4 is 3. So our final answer is that. And in graphing it on the number line, so we're at 3 and 6 for boundaries. 3 is a closed circle because it's equal to, and it's less than 3, so it's that way. Or it's greater than 6, so that way. See you in class tomorrow.